The molar equilibrium constant of pure water, that is at 25 degrees centigrade, that is Kw. We know it is 10 to the power 14. This is also called the ionic product of water. So over here our answer will be C. Next question is, which of the following represents the correct order of acidic strength among the boron halides? So over here we have to think in terms of back bonding. Okay, now all the boron halides will act as a Lewis acid because it has a empty p orbital. Okay, now the lone pairs that are present on the halides can also be donated to the empty p orbital of the boron. So this p orbital is 2p, right? So if we have a fluorine over here, then the donation happens from 2p. The energy gap between 2p and 2p is very less, so there is better donation or better back bonding from fluorine. However, if you go to 3p, because the energy gap increases, back bonding becomes less. So if you are filling up the empty p orbital through back bonding, Lewis acidity will reduce. So we will say Lewis acidity is basically inversely proportional to back bonding. Okay, so it will be less for BF3, more for BCl3, even more for BBr3, and highest for Bi3. Okay, so answer will be B. What is the degree of dissociation of 0.1? So this is the molarity of aqueous solution acetic acid 20 degrees centigrade having a specific conductance. So here it has been given, and the specific conductance given over here, that is the kappa, and over here we have been given the molar conductivity of acetic acid at infinite dilute solution, that is this one. So we know alpha is this by that, and to calculate this we will use the formula kappa 1000 0.01. So over here we know 1.63 into 10 to the power minus 2 into 1000 by this. So that is basically, we will say this and that gets cancelled. So it is, rather we will say 1.63 into 1000. Okay, so that is 163 this. Okay, that is what we are getting, S meter square mole inverse. Okay, so over here, if this is the value, and then what we will say, this will be equal to what? This divided by that. So I think this should be plus, okay, not minus. So over here it should be 16330 divided by 390. Let's leave it this one. It should be let be minus only. This minus 4. So let's calculate. If we calculate, we will get That is 163 divided by, let's say, 39. Okay, so I think it should be plus and not minus over here. So it should come like this. This should be our answer. Next, which one of the following factors affect the ionization energy? Obviously, atomic size increases, ionization energy should decrease. So atomic size, you should say, will be inversely proportional to ionization energy. Nuclear charge increases, IE increases. Also should be involved with the type of electrons, because over here, if it is in the S orbital, then it should be requiring more ionization energy, then P, then D, then F. So highest should be from the S orbital. So we should say 1, 2, 3 are the correct answer over here. Okay. pOH and pH of a 6 into 10 to the minus 2 molar solution of NaOH will be what? We have to find out. So basically we know pOH is minus log to the base 10 OH minus concentration, that is to be said that is 2 minus log 6, or that would be 1.23 for pOH. So pH will be 12.77. Okay. Which one of the following is used for calibration of pH electrodes? Obviously we will be using a buffer solution. What will be pH of a buffer solution prepared by mixing of 10 ml of 0.1 molar acetic acid and 10 ml of 0.1 molar sodium acetate? So and the pKa of the acid is given. So what we have to do over here, we know pH equal to pKa log salt concentration by acid concentration. So it is 4.76 plus log of 10 ml of this and 10 ml of that, right? So salt is 0.01 by 20, and that is going to be 0.1 by 20. That should be the concentration. Okay, so this and this gets cancelled. Alright, so we are having out here basically 4.76 log 0.1. That means 4.76 minus 1, that is 3.76, or we can say it is equal to